In this video, we are going to see the demonstration of a new program which converts a simple 2D model and assemble it into a complete 3D with all the components. So this is that particular tool, and we have several modules of it. So it can create a win column, it can do translational repeat, it can add strut tube to your model, and similarly the bracings. Then the wind load. Why specifically wind load? In the sense wind load is the most time consuming load to apply for a huge structure. That's why I created a separate module for wind load alone and the design parameters. And this will be helpful to apply design parameters for multiple members in a fastest way. So moving on to the demonstration, this is a simple 2D frame. Any engineer when they start a particular project, initially they will prepare one 2D STAAD model. From that, they would extract the weight, they see the deflection, and they could get the look and feel of a structure. Without that, it is hard to understand a structure properly. So once we are moving on to the detailed design stage, we require a complete 3D STAAD model, and obviously, it is going to take around minimum of 45 minutes to 1 hour to prepare a STAAD model, 3D STAAD model from this 2D one. Considered we have optimized everything in a 2D, it might take a minimum of 45 minutes to 1 hour. And if the model is huge, then ultimately it is going to take days. With this particular program, we can do that particular task in minutes. Let me get into the demonstration. So whenever we create or convert a 2D model to 3D, the first thing we do is we create a win columns. It is because we want where our win columns would be connecting at the top, because we want that nodes for creating bracings and strut tubes, right? So similarly, we are going to create a win column here first. Say my win column spacing is 3 at 6975, and my Z position of this particular frame is 0. My base level is here, you can change the win column base height, say minus 500 mm from FFL or plus 1.2 meter from FFL, like that. Here I'm going to use minus 500 mm. Then for profile type, you have three options. You can choose hard roll section. Based on these libraries, you can provide a section name over here, or built up straight and built up tapper. For this, I'm going to use a built up straight, and I'm going to provide the start depth as 262, which is web depth plus top flange and bottom flange. Next 5, next 262, 156. Yeah, that's fine. And each time before adding any component to the model, you have to update the structure. So all these modules will be having an update button at the bottom. Before adding anything, please do update. First, I update the structure, then I add my win column. Yeah, that's fine. Next, moving on to the translational repeat. So my base spacings would be 7500, 5 at 8000, and 7500. So my first and last bay would be 7500, and the intermediate bays are 8000 mm. So before selecting, I will update the structure. Then I will select what are the components which I want to do translational repeat. Yeah, these are the components. I just pick those things, then perform translation. Yeah, it is done. Now we have to add same win columns at the end as well, right? So I'm going back to win column module here, same minus 500. Instead of built up, now I'm going to provide a hard roll section, say Indian ISMB 250. Yeah, that's fine. Before adding, I just update. We forgot to put the Z position. The Z position of the last frame is, I think, 55 meter. Yeah, it is 55 meters. So 55,000. Let us update. Then let's add. Yeah, that's fine. We got our win column here as well. So it is ISMB 250, and you could see the columns were oriented 90 degree to the main frame. That's fine. We have our win columns now. All we have to do is next this strut tube. It supports Tata structure strut tubes, and I'm going to provide 139.7 this section. So Before doing the selection, let me update the model. All we have to do is like we have to select the nodes where we want the strut tubes to run. That's all. And going to the program, let me add strut tube. Yeah, strut tube is done. Next, moving on to the bracings, we have option for roof bracing and wall bracing. Roof bracing, obviously, like we are going to do with diagonal pattern. So like we have profiles here. We have solid rounds as well as single and double angles, and then CHS sections. Say for example, if this is my braced bay, let me choose all the strut tubes along that bay, and then going over here. Like before selection, you have to update. Sorry, I forgot it. Let me update. Then let me select these members. I'm going to provide a solid round of 24. Yeah, then add. Fine. Update the structure. Select the members. Now, like, let me add a double angle and roof bracings. Yes, that is fine. So we have double angles. Then the wall bracing. Update the structure. You see, for wall bracing, we have two options. Either like we can add a diagonal bracing or a portal bracing. Let us like add a portal bracing along this near side column and rod bracing on diagonal bracing on the far side. So for near side, since we are going to add a bracing in this position, these strut tubes will not be there, right? So I am deleting it. I will update the structure. Then portal bracing. Here it is asking for portal column and beam section. Say my portal column is 250 to 400, 156 and 400 straight section as my beam. So all you have to do is like select the columns and then add a wall bracing. Yes, it is done. Similarly here as well. See, that's easy. So on the other side, since we are going to provide a diagonal bracing, so I'm going to add say a circular section. Add wall bracing. Add wall bracing. Yeah, we have completed our model nearly. So like the modeling is nearly over. All we are pending is with like applying a wind load, then design parameters. Obviously, like you have to do the load combination creation, and then you have to optimize the frame. That is like your task. For the model is complete, right? So with this tool, you can add these four components whenever you want. Say for example, you want bracing in this bay. You just go there, select the members. It is like say route 24. Before that, update the structure. I forgot it. Sorry. Select the members. Add roof bracings. Yeah, it is done. So like for wind load, for application of wind load, all you have to do is like you have to paste the wind load coefficients here. You have starting wind load number. You have to go and check here. What is the start wind load number here? Then you have to put that number over here. It is 3, and say I'm going to apply loads for these 3 members. It is end wall column 1. Whatever coefficient which we are going to provide in this end wall column, it is going to calculate load for these coefficients based on the pressure and tributary area, and it will apply on these load combinations, primary loads over here, right? Say I have for the purpose of simplicity, I just copy one every for all the coefficients, and pressure 1, say my tributary area is 10. That is fine, right? So for these columns, before selecting them, let me update the structure. Let me select them, then add wind load. Yeah, wind load is created. If you want to see updated, then go. Yeah, 10 is applied over here. Similarly, say this end. So it is involved 2, and for to see the variation, let me apply a 5 mm tributary and add wind load. Yes, it is done. You could see the loads over here. So it is 5. So the wind load is applied. Similarly, if we have different base spacings, say like 7.58, 6.5, 8.3, like that, if you want to apply a separate wind loads for each and every frame, or what you have to do is like you can collectively select these, like the frame members. Say this is a near side column, right? So near side wall. Say these are my coefficients and these are my pressure. You just press update. It will add that particular load to the selected members. Yeah, like with this program you can create a wind load for whatever members in your frame or like in your model, right? Then moving on to the last piece, the design parameters. Here, we are adding several members, right? We have to add design parameters for each and every member. For that, like you can select the members, and mostly the most used parameters are provided over here, considering Indian and MEMA design. So my win columns say KZ is 1, LZ is 6.5, LY is 3, LX is 3.6. Then since it is Indian, it doesn't have UNT or UNP. My FY is 250, and the 410 ultimate, it is like I provided straight build-up section over there. So STP 2. Sorry, I didn't update the model. Update it, select them, just apply. The parameters are applied. You can go check it over here. Yes, simple now. Similarly, for these three members, I will change this to 1 and 1.8, 1.5 to see this like variation. Yes, you can see the parameters are added over here. See, right? So that's all for the demonstration of this video.